All right. So yeah, I'm super thrilled to talk about Delos. I think it's a cool paper. All right, but let's jump into things. It's a pretty interesting paper. It's pretty technically rich. I can't say that I understand it fully, but I think that we'll still have some interesting things to talk about. Okay, so let's dive right in. Delos. I'm going to start actually with a bit of background. I'm going to talk about how to do reconfiguration in vanilla multi-Paxos. So let's talk about multi-Paxos reconfiguration. Okay, so remember with multi-Paxos, we're going to have some number of proposers. One of the proposers is going to be elected the leader. So I'll draw it for the crown. That's the leader. And we'll have some number of acceptors, let's say A1, A2, and A3. And we'll have some number of replicas, let's say R1 and R2. And remember that multi-Paxos, the whole point of multi-Paxos is to have some log. So I'll draw the log. All right. And now when some client wants to get some command chosen in the log, it sends the command, let's say X to the leader and says, hey, leader, please get this thing chosen. The leader, oh, and also I want to draw these guys in a color. The leader will then send the command to the acceptors and say, hey, here's X, can you please get this chosen? They'll respond, yeah, sure. The leader will let the replicas know, they'll put it in their log, and life is good. Okay, but let's say we want to reconfigure, which means we want to change the set of nodes executing the protocol. So let's say we want to change to a different set of acceptors. And let's take a look at what happens if we try to do this naively. We'll see that it's not going to work out so well. So let's say the leader is like, you know what, these A acceptors, I don't like them anymore. I want to switch over to a different set of acceptors, a set of B acceptors, B1, B2, and B3. Maybe this is because the A acceptors all fail, they're, something, it doesn't really matter. And let's just say it just decides to change. It doesn't do anything fancy, it just says, forget the A acceptors, I'll use the B acceptors. So now when some client sends a command Y to the leader will send to the B acceptors instead. It'll get the command chosen, let the replicas know, and it'll put Y in the log. So this is the naive way of doing things, and this is not quite correct. The issue is we have this other proposer, P2. So let's say some other client shows up, and it contacts P2 with a command Z instead of P1. And let's say P2 is partitioned from the leader, so it thinks the leader is dead. Okay, so P2 thinks, I think P1 is dead. It seems like he's dead. So this guy will also become leader. He'll appoint himself leader. Oop, I thought I turned off that. And then it's going to run Paxos, but it doesn't know about the B acceptors. It only knows about the A acceptors. So it's going to contact the A acceptors, and they don't know they're not acceptors anymore. And it'll get Z chosen. So now we have two commands, Z and Y, both chosen in the same entry, which is like the one thing that Paxos is not supposed to do. So this is broken. And this is broken because the two different proposers think that the acceptors are different. The bottom guy thinks A1, A3 is the acceptors, and the top guy thinks B1, B2, B3 are the acceptors. Okay? So we can't have two different leaders, two different proposers thinking that there's different sets of acceptors. So we have to reach an agreement. At every point in time, we have to agree. Who are the acceptors? Well, in order to solve agreement, we have to use consensus, and thankfully we have consensus, that's the protocol itself, so we can leverage the protocol to choose the acceptors. So what does that look like? It's gonna look something like this. All right. So I'll erase all this. All right. So let's say X is still in the log. And then it gets this command Y, the leader gets the command Y. And it says, okay, I want to switch over to these B acceptors now, but now we know I can't just switch. I have to make sure we all agree. So what I'm going to do is I'm going to get the set B, which is B1, B2, B3. I'm going to get that chosen in the log itself. That way we all agree on who the acceptors are. So it'll contact the nodes in A and say, hey, I want to get B chosen. They'll choose it, they'll let the replicas know, and now B is in the log. And then I can keep going and get command Y chosen for the B acceptors, like this, put Y in the log. And if some other client shows up and sends Z to P2, I no longer run the risk of P2 somehow running with the old acceptors. Because when it talks to the old acceptors, it'll learn that B was chosen, and then it'll say, oh, okay, I have to use the new acceptors, so it'll go contact the new acceptors in B. So we have to agree on the acceptors, so I'm gonna do that by putting the acceptors in the log itself. And maybe the protocol keeps running and we get Z chosen and A chosen, and maybe later we perform another reconfiguration to some log, some acceptors C, and maybe I don't know, B is chosen and so on. And what's happening here is that the log is getting split up into these different regions. So in this first region, we choose this with A. So the A acceptors choose this. And then we have this region of Bs. So this region is chosen by the Bs. And then we have this third region chosen by C, which I have not drawn. And so on. So that was what? That was C. So I have different segments of the log. That's one segment, that's one segment, oops, and that's one segment. I have different segments chosen by different acceptors. And this style of reconfiguration is called horizontal reconfiguration. All right. The main idea of Delos is, okay, we can reconfigure, different chunks of the log between different acceptor groups. What if instead we reconfigure different chunks of the log across completely different protocols? So instead of having different segments by different acceptor groups, we're going to have different segments of the log by completely different protocols. All right, so this is sort of like a generalization of the idea up here. Instead of chunking up the log and making them chosen by different acceptor groups, I'm going to have them chosen by completely different protocols. Maybe Raft, and then maybe Paxos, and then, I don't know, some other Paxos, and so on. Okay, are there any questions so far on the main idea? Okay. So at a very high level then, how are we going to do this? Well, in Delos, we're going to have our Big Daddy virtual log. So from the client's perspective, up here we have all the clients. From the client's perspective, we just have a normal vanilla log. And we call this the virtual log. And then we are going to have this oracle called the metastore. For now, I'm just going to think of it as this holy oracle. So we'll draw it with a halo. It's this all-knowing being. And this oracle is going to keep track of sort of what is the current state of the virtual log. And the virtual log is going to be chunked up into a number of loglets. So let's look at, maybe we have Raft. So I have some implementation of Raft that's running. And these guys are called loglets. All right, so the protocol is going to run essentially at a high level like this. The metastore is going to say, okay, I'm going to map chunks of the log into these loglets. And at first, the entire log from 0 to infinity is owned by Raft. So if I'm some client, I'll send a command to Raft X, it'll put X in the loglet, and then therefore it appears in the virtual log. And maybe I get Y chosen, so Y goes in here, Z chosen, and Z goes in here. And then at some point, the oracle says, okay, hold on, I'm going to stop Raft, I'm going to reconfigure, so it's going to freeze the whole thing. And then it's going to update its policy. So now it's going to say, okay, 0 to 3 is Raft. And now 3 to infinity is maybe Paxos. And I'll launch some Paxos instance. and it'll have its log. And maybe now I start getting command A chosen, and that'll show up here, B, that'll show up here, and so on. And so we see that we have these different segments of the log mapped to different loglets in much the same way we had different segments of the log mapped to different acceptor groups. Okay. So this brings up, yeah, so one thing to note here, it's subtle, it's maybe a minor detail, but with the ranges here with 3, this is exclusive. So 0 to 3 means 0, 1, and 2. Okay. So now we have a couple of questions though. How do we implement this Oracle, the metastore, and how do we implement the loglets? So before we dive into those details, are there any questions so far on the high level of what we're trying to achieve, or at a high level of how these things work? No. Okay, good. So far, I think it's pretty straightforward. So let's look at the metastore first. How do we implement the metastore? And it's very simple. The idea is we're just going to use horizontal reconfiguration in multi-paxos. So I showed you guys multi-paxos at the start. I did that not only because it was a good sort of motivating segue into Delos, but also because concretely that is what they use to implement the metastore. So I talked about horizontal reconfiguration and multi-paxos. That is actually what they use to implement the metastore. And what we're going to do with this horizontally reconfigurable multi-paxos protocol is implement a single versioned register, or a versioned register, which is just a single value that can change over time. And every time I change the value, it gets some new version. So maybe it starts off with version 0, and it says the log from 0 to infinity is raft. And then I update it to some new version, v1, and that maybe would be 0 to 3 is raft, and 3 to infinity is paxos. And now some client is going to send updates to this configuration, to this Oracle, to the metastore. And the updates are all conditional writes. So it'll say if the version is v1, which is what I hope it is, that's what I think it is, then update to maybe 0.3 is raft, 3 infinity, oh no, not 3 infinity, 3.10 maybe is paxos, and 10 infinity is, I don't know, w paxos. So I'll send this conditional write. The Oracle, the state machine replica, will say, oh, okay, the version is v1, so I'll go ahead and update my version to v2, and I'll update it to this value. And maybe later, some other client shows up, and it says, okay, I think the version is v1 still. Oops, if the version is v1, then update to, and it has some configuration. Now the protocol is going to say, no, sorry, buddy, you're a little late. My version's already v2. You think the version is v1. You sort of are living in the past. So you have to go get the new version and then try again. This just makes sure that if 2 people are trying to talk to the Oracle at the same time and say, here's what the configuration is, and someone else says, no, here's what the configuration is, as long as we have the versions and the conditional writes, we're always going to have this sort of logical chain of configurations, and they're never going to fork or anything like that. All right, so summarizing that is multi-paxos plus horizontal reconfiguration plus the version register means I have this consistent Oracle, this consistent value that changes over time. All right, so the metastore is the easy part. The loglets are the harder part. Loglets. Okay, so let's talk about some of the problems that can happen with loglets, and that's going to motivate the API we're going to have to implement. So let's take a look at the virtual log. And let's take a look at a configuration where I have raft. So I'll have a raft loglet. And let's say I choose X and I choose Y. So that shows up in the log. And then I'm going to perform a reconfiguration to Paxos. So now 2 to infinity is Paxos. And Paxos will show up. Maybe I get A, B chosen. So far, so good. But then let's say that some client who's communicating with the protocol hasn't looked at the metastore recently. So if you remember from the paper, the clients cache the current configuration. And they go to talk to Raft. And they think that Raft is the only loglet. It's living in the past, and it thinks Raft is the only loglet. So it might send something like maybe Z over here to Raft. And Raft, it also, this is doing everything naively. This is not implementing seal. Raft might think, well, I'm still good to go. You know, I don't know anything about loglets. I'm just a protocol. And it'll get Z chosen. And now all of a sudden, is this A or is this Z? So what I'm trying to point out here is that a problem we have to make sure to avoid is once I've changed to a different loglet, I can't let clients choose commands with the old loglets. So I have to seal loglets. We'll see that's why we have to do seal. Okay, so that's one problem. But there's another problem. And that is, let's say a client sends X to Raft. For whatever reason, it doesn't get chosen. Some other client sends Y. So I put Y here and Y goes here. And then because I learned from the first problem, I have to seal the protocol. So I seal it. I switch over to Paxos. And now Paxos starts getting commands chosen in it. A, B, C, and so on. Except now my protocol is stuck, right? I have this big hole right here. I have a hole. So the next problem, problem 2, is I can't have holes. And these two problems are kind of in conflict. The first problem, I said, I have to shut down a protocol completely and say, stop choosing stuff. But this problem is, well, I can't shut it down completely because when I shut it down, I still have to make sure there's no holes. And the loglets and the API behind loglets is going to be designed in a way where I can do both of those things. I need to shut down a protocol while also making sure I don't have any holes. Okay, are there any questions on that, like what these problems mean and why I have to avoid both of them? No, okay, clear so far. Oh,
I guess.
You had something? Oh, Jesse?
Jesse,
oh, hold on.
Yeah, sure.
Go ahead.
Check.
Yeah, I can hear you.
Okay, cool. I am not familiar with how Raft could get a hole in the log.
Yeah, Raft, I think Raft maybe can't. But in something like multi-Paxos, you definitely could.
Okay, cool.
Yeah, could you in Raft? Yeah, I don't think so.
Yeah,
yeah,
not to my knowledge.
That's a good point.
Okay, yeah. Cool. We can keep going.
Yeah, no, that's a great point. Maybe I shouldn't have chosen Raft. I should have swapped these two.
Okay, so let's imagine that there's a thing which can skip a slot for some reason. It just fails to get consensus and tries again in a new slot, I guess.
Yeah.
And then that creates a hole in the virtual log.
Yeah. Yeah, yeah, like multi-Paxos, you can imagine when I do pipelining, I don't want to wait necessarily for the old things. I'll just get them chosen. But yeah, that's a great point. That is a great point. Okay. So now let's dive into the API of loglets. And I think it's a little more, so when I read the paper quickly, everything made sense to me. And then when I read it a little more carefully, I realized that there's some nuances and subtleties going on here. So seal, we're gonna talk about like sealing at a high level. It's like, oh yeah, just seal it, just like shut it down. And then check tail is gonna be like, yeah, like just, you know, after it's shut down, look at the tail. But I think that understanding the exact semantics of these two API calls is actually a little more subtle, and to really understand things, I think we have to understand those subtleties. So first I'm going to talk about a distinction I think the paper is making, which is the difference between a command being successful versus being chosen. The paper doesn't use these words. I'm making these up, but I hope it'll be helpful. So let's say we have some state machine replication protocol, and I'm some client over here, and I send some command X to the protocol, and I say, hey, protocol, please get X chosen. And it sends back to me a response that says, okay, and I'll put that in log entry 1. I'm going to call this a successful command. And the successfulness means, successful here means that the command is guaranteed to be chosen. And I'll explain what chosen means. By chosen, I mean that when I then later say, hey, what is the command that's in log entry 1? It will return to me X. So when I say something's chosen, I mean it is returned by a get. Okay, this is not super formal, but I think you get the point. Successful means I send something to the protocol and it says, yeah, you're good, we're good here. And chosen just means like, okay, I can go get that thing now. But it's also possible that some client sends some other command, let's say Y, and the protocol either never responds or maybe it says, no, sorry, I can't choose this. So this would be unsuccessful. But we'll see with the protocols, it might be the case that if I get some random log entry, let's say 2, it returns with Y. So I'm going to say that unsuccessful means might be chosen. Unsuccessful doesn't mean definitely not chosen. We'll see cases where the native loglet will not successfully, it won't be successful, but it will still choose things. So if I'm unsuccessful, I may or may not have that value chosen. I'm not actually sure. Okay, so now let's look at the Loglet API. And I think this is where the distinction comes in. Or actually, wait, is there any questions on that first? Sort of what I mean by successful and chosen. Okay. All right, so the Loglet is going to support 2 APIs. The first is, well, it'll support a bunch of APIs, but the 2 interesting ones are seal. And this says any commands, let me make sure I get this right. Any commands sent after a successful seal, after a seal finishes, will not be successful. But they might be chosen. So there's a part in the paper where they talk about this subtlety of phantom commands, I think they call them. It's like I seal something and then all of a sudden commands start getting chosen. So this means that once I seal, if I am a client and I send something after a seal, I won't succeed, but that command might spontaneously be chosen anyway, right? So that's already a little subtle. I mean, it would be great if we could just say, once I seal, nothing's chosen. But if we did that, then we would have holes. So this is sort of allowing us to fill the holes. And the second thing is check tail. Murat, did I repeat the thing you want to repeat it? Did you want me to talk about the successful thing?
Yeah, Alexei just sent me an explanation, so I think that's good.
Okay.
So if I still have questions after this, I'll ask.
Okay, and when we talk about loglets, I'll also show a concrete execution where something is unsuccessful but chosen. So we'll see more concretely how that can happen, because it seems weird that it does happen. Okay, so check tail. This returns in a log index. And the check tail is a little subtle too. I'm going to say that after a call to seal has finished, check tail returns a log index I such that, 1, every successful command, every chosen command, every successful command is chosen in some log entry less than or equal to I, and 2, all entries less than or equal to I chosen. Okay, So when I get a tail, right? Remember that. Well, did I even show this? Oh, I'm about to show this. Remember that when we do the loglet reconfiguration, I'm going to seal a loglet, and I'm going to call check tail, and then that tail that I get is going to be the end of that loglet, and then I'm going to start over in the new loglet right after that tail. Check tail, I need to make sure that there's no holes. That's the second point here. All entries less than I are chosen, and also to make sure I don't lose any chosen command, any successful commands. So if some client said, here's a command, and it said, yeah, you're good, successful, and then I reconfigure and I lose it, that's also bad. So I can't lose anything, and I can't have any holes. And seal also makes sure that I don't get anything successfully chosen in the future either. Okay. So let's see. Yeah, let me walk through this now. Is that because of a repair? Yes. Yeah. So Mustafa's asking, is the whole successful chosen thing, do we get some weird things because of the repair in the native loglet? Yes, and we'll look at that. That's exactly right. And we'll see that, like, we'll get to it. Okay. So with this API, I'll sort of go over again. Yeah, might as well. I'm going to sort of go over the protocol again, but now with the APIs. All right, so that's our virtual log. We have our meta store. And let's say we start off with Raft. So we have Raft. Okay, and let's say the following happens. I'll go X, that's successful. I'll go Y, that is not successful, but it's chosen. I will go Z, no. Now I'll go seal. Okay, that'll say, okay, that'll be successful. Now I'll send Z. Okay, here's a pop quiz to make sure everyone's understanding. Mustafa, I see your question, we'll get to that. Here's a question though. Will Z get successfully chosen? The answer, no, exactly. Because I just sealed, Z cannot be successfully chosen. But can Z be chosen? Yes, so maybe Z gets put in the log. But not successfully. I think you guys can kind of see the subtlety here. So it is put in the log, it's not successful, it was chosen, and then I'll call checktail, and checktail is going to return 2. Okay, so 2 is my tail. So I'm going to do my reconfiguration now. Instead of 0 to infinity, I'll go 0 to 3. And 3 to infinity is now going to be like Paxos. All right, so I have Paxos over here. And Z will get copied over here. And this region, this is like the Raft region. And all the stuff afterwards is going to be the Paxos region. And maybe later someone shows up, even after a checktail, I think this is still possible. And they say, put something in A. A could maybe get put in the log. It won't be chosen. It won't be successfully chosen, but it could be put in the log. So we see that there's some kind of confusing things here. Let's say X was both successfully chosen and put in the log. Y was not successfully chosen, but put in the log. Z was not successfully chosen, and it was after a seal, and it was put in the log. And A was not successfully chosen, was chosen after a seal, but not put in the log, the virtual log. So we see that it's kind of complicated, the interaction between seal and checktail and when things get chosen and if they're successfully chosen. Okay, let me go on to the native loglet to see more carefully how these things are happening. Yeah, so we had some questions, right? Okay. But it won't be in the virtual log though, so we're good, right? Yeah, so we'll see. That's a good question, Mustafa. I would say that as long as we satisfy these properties, everything's going to be correct. Maybe I have things that were not successfully chosen show up in the virtual log, but that's okay. Maybe I have some things that were chosen that don't show up in the virtual log, but they'll be unsuccessful, so that's okay. So I think as long as you satisfy these properties, we're going to be okay. And then Jonas says, is this consensus? Which part? Ah, okay. It went over my head.
Okay, so what is the difference between Z and A? Both come after the seal. Both are not successful, but one is in the log, the other is not. Is
Yeah.
it because the seal is followed immediately with checktail and that includes Z, but after checktail, A comes, so A is not in the log, in the virtual log?
Yeah, so I can try to answer this. I will have to say that this starts to get into the territory where I don't actually understand the protocol fully. And that's because the protocol has this call called, I think, read command or get command or something like that, which is the thing which says like, hey, what's the actual command in this log entry? And when you look in the paper, it says that there is some restriction on calling that function and calling checktail. It's something along the lines of like, I can only read an index if it is less than my own previous successful call to checktail. So Murad, your question of like, if I were to call read of 3 on Raft, would I see A? How come I don't see A, but I do see Z?
Mm-hmm.
I don't understand it fully. I think it has something to do with like, I'll call checktail, and if checktail is something weird, I have to sync with the metastore. I think the super formal answer is like a little complicated, but intuitively, the high level answer, the way I think about it is, once I reconfigure from Raft to Paxos and I put in like the upper bound over here, the 3 in my metastore, everything after that in the loglet, I won't see in the virtual log. Does that make sense?
Mm-hmm.
Yeah. Sorry, I know it's not a super good answer. I think this is sort of where the protocol gets pretty hairy. Okay. Are there any other questions before I talk about the native loglet a little? Okay. All right. So when we talk about the native loglet, I think some of these complexities will become a little more concrete. Okay, the native loglet. I think this is cool. The cool idea here is that we have the metastore, and the metastore implements consensus. It's strongly consistent. And because of that, the loglets, I don't know how to say this like super formally, but essentially I don't need to be as available. Right? So the cool idea here is that my loglets don't have to be as available. And we'll see what that means here in a sec. Okay, so what is the native loglet? So the native loglet is one particular implementation of a loglet. That's the one they talk about in the paper. And here's the way it works. I'm going to have 2f plus 1. I don't know what they're called. Log servers, I think. And one of them is going to be a sequencer. So I'll draw that with a crown. And each of these guys is going to have a log. All right, so the native loglet is like, imagine I'm running multi-Paxos, but I only have one leader and I never do leader reconfiguration. And if the leader fails, I'm just out of luck. So clients will send their command X to the sequencer. The sequencer will put it in its log and it'll forward it to the other servers. When they get it, they'll put it in their log and they'll respond. And when it hears back from the majority of the servers, the command is chosen and successfully chosen too. It'll respond to the client. So if this sequencer fails, my protocol cannot successfully choose any more commands. Though we'll see that we can still choose commands, but I will not be able to successfully choose any commands because the sequencer is the only one who responds to the client. So in that sense, that's why I'm less available than like normal multi-Paxos, because in normal multi-Paxos, I can just select a new leader and keep going. Okay, so now let's look at how seal is implemented. Let's say I send seal to the majority. So I send it to all of them and wait for a majority. Maybe here it just manages to get to these two. And when a server gets seal, it's going to just keep track of a single bit. It's going to say, okay, I'm sealed. It'll respond, okay. And then maybe some other client shows up with a command Y. And this is now going to get sent to the other guys. But when I'm a server and I get a command from the leader and I'm sealed, I'm going to reject them. I'm going to say, no, buddy, I'm done. You know, I quit. I'm done choosing commands. So here the leader, or sorry, the second server will respond, no, I'm sealed. I won't choose this command. Oh, I forgot. So the leader, the sequencer will put Y in its log, but the other nodes won't. They'll refuse. Okay. Now, let's say someone calls checktail, and checktail is going to go to the top two. So here's checktail. The way checktail works is I'm going to send checktail to these servers, and the server is going to tell me. Another detail I skipped over is also we don't have holes here locally, so nodes will put things in order. They won't do holes. That's similar to Raft, and that's a little different than multi-paxos. They will tell me, okay, what's the first empty, like sort of what's the longest prefix of my log? And then they'll let me know. So here, the first guy will let me know. He'll say, okay, I have the first two, and the second guy will say, I have one. And I say, okay, well, this is a problem, right? Now I might have holes, right? X, Y is longer than Y. So what it's going to do is it's going to have this command Y copy over, this is also called the repair, I think, to the other logs. All right, so if one of my servers has a longer prefix, it's going to copy its prefix over to the other ones. And then the check tail will ultimately decide on two. The largest of the logs, that's the tail that it returns. Okay, so there's a couple things to note here. Let me say this Y, for example. Now this one is chosen, but not successful. So this is concretely how that can happen. Something can be chosen, but not successful. If I send it to the leader, for whatever reason, cannot get it chosen, maybe because other nodes have been sealed. But then later during a checktail, it says, no, I'm going to actually get that command chosen and send it to the other replicas. Another thing to note is that this is safe. So, you know, in normal multi-paxos, this is like crazy. I can't just like look at an entry and just say, just copy it over to everybody else. But this is safe because this is the only value proposed. The leader is the only one who even ever proposes anything. I can't have another leader come in and propose a different value in this slot. So it's safe because it's the only thing that could ever possibly be chosen. It's the only thing even proposed. And then also this copying removes holes. Not quite, okay, so there's even more complexities in the paper I'm skipping over, like the native log servers have this notion of it knows the command is globally chosen, so it doesn't locally choose it. So there actually would be holes, and it's actually a little more complicated, but I'm not going to get into that, mostly because I don't fully understand that. Okay, so I think that's actually it for the technical stuff before I wrap up. Were there any questions in the chat here that did not get answered? How to seal start outside sequence variables. Sequencer is pre-chosen. Yeah, so it seems like people are sorting out in the chat. Are there any other questions? No, okay. I think maybe earlier in the talk there were no questions because it was too obvious, and now maybe there's no questions because it's too complicated. This stuff I think gets a little tricky and subtle, and I'm simplifying a lot. Okay. Maybe we can get to some of these questions in the discussion. So let me summarize now. I think there's a lot of sort of details here, but I think the high level idea is very nice. I would say that the summary is twofold. One, reconfigure across protocols using sealing. I think at a high level, that makes a lot of sense. Take a protocol, shut it down, switch to a new one. And the second cool thing, I think, is that we can separate reconfiguration into a strongly consistent part, or what should I say, into a highly available part, the metastore, and a less available part, the loglets. I think this idea of sort of separating things out and then taking advantage of that by making certain components simpler. Like for example, the native loglet is simpler because I don't have to do leader election. I can just assume a fixed sequencer and whatnot. I think that's a cool idea. I'll do a slight humble brag and a shameless plug. We submitted a paper recently on matchmaker Paxos. And we do actually a cool similar idea. I think you can even go further than this and make it so that neither component is necessarily super available. See, there's some cool tricks. There are other cool tricks out there. Okay, and then I'll finish with just a random idea I had because I thought it was cool, and then maybe we can talk about it in the discussion. So when I was reading through this, I really like the argument that the native loglet can be simplified because it doesn't have to be as available. I don't have to do leader election. I can have a single predetermined leader. But when I started reading through things more and understanding that seal and checktail were a little nuanced, things can get chosen but not successfully, and I can have phantom chooses, and checktail can return higher and higher values. And I have to make sure that my read interacts with checktail. I realized that we were getting some simplicity, but at the same time, this checktail and the seal themselves are adding more complexity. So we lose some complexity, but we get back some others, I think. My idea was, what if you said, I want to do this idea of reconfiguring across protocols, but I don't want to have to implement new functionality. I don't want to have to go to Raft and implement a seal. I don't want to think about seals and stuff like that. I just want to not change the underlying protocols. So this is more of like a black box approach or like a shim approach of like, I don't want to change as much of the protocol. Can I do that? And I would argue maybe that's simpler because then I don't really have to think about these new things. And this is just a random idea I had, so obviously it's not fleshed out. But I was thinking maybe you could do something. And my idea was, why maybe I can leverage the state machines themselves to seal. I don't have to introduce a new seal. I'll just use the log itself to seal. And maybe one way I could do that is, let's say I have Raft. I will simply, if I want to seal something, so let's say I have X and then I have Y, I will simply have some special command, maybe I'll call it stop, and I'll just choose stop in the log. I'll just say, hey, choose the stop. And then the clients know that if they ever have some command chosen in the log, but it's after a stop, they'll know to consider that not successful. They'll say, oh, oops, if it's after the stop, I can't get it chosen. And then the holes I'll fill just by doing normal consensus. I'll, the protocol has a stop in it, but the protocol doesn't know what stop means. It can still run and get things chosen. So I'll just keep getting things chosen up to some stop.
I think the reason that they didn't want to do this in Delos is that they didn't want the loglet to have to be available for writes in order to seal it.
Yep.
Right, so if you can lose a leader, then you can't accept any more writes. You can still accept a seal because of the way they did it, that you can write a seal out of band to a majority of the survivors without a leader. Mm-hmm. And then what's cool about that is that they can, instead of electing a new leader on a loglet, simply reconfigure the entire system to use a new loglet that has a leader.
Yeah.
So that they avoid having to implement election. I agree with you that if Raft is the underlying loglet and Raft is available so long as there's a majority surviving, then this would work.
Yeah, no, that's a great point. Yeah, I think that describes it perfectly. I think, yeah, it's like a trade-off. It's a trade-off of like, how much complexity is it to introduce the availability given a failure versus the complexity of adding a seal? And then you also have to think about, well, my protocols mostly already implement state machine replication anyway, so it's not really more complexity because they already do it. And yeah, I think it's just a trade-off. I don't think either idea is better. But I thought it was at least interesting to think about, sort of a more black box approach.
Right. So stop could have been written by majority write from outsider, right? So that's the idea. Even when the sequencer is not available, you could still reach to that also complicates things.
No, that would be similar to the fast Paxos idea, right? And then
Yeah.
in the end, you still need some sort of leader or to choose the right one in that slot.
Mm-hmm.
Yeah, so for my
I
stop,
think-
oh, sorry, go ahead.
I think what's really strange about the seal operation is that it's not sequenced the same with other log entries on all the nodes in the group. So in Raft, everybody agrees on the sequence of log entries, although some nodes might be behind. But in this system, since everybody's available for the seal write, one of the nodes could have A, B, stop, Z, and another could have A, stop, B, Z. Which might be okay, but it's hard to reason about, and it's not how we're used to thinking about Raft.
Yeah, yeah, I agree. I completely agree. And I think the complexity comes from like, because they're stopping at different points and like some of them might have holes. I want to just stop, but I can't because like I have to fill the holes. So it's like I have to keep getting things chosen, but at the same time, I intuitively don't want anything chosen. Yeah, so I think, yeah, there's that weird sort of deal going on. But yeah, that's all I had in terms of presentation material. So I think we can just go into the discussion.